Good morning, good afternoon, and good evening. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from March 2025, Paper 2, Variant 2. As always we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 1, part A says, explain what is meant by the accuracy of a measured value. So what exactly is accuracy? Very important concept. Accuracy and precision. Accuracy, in a simple language, we can write down first of all, what is accuracy? Accuracy is linked with correctness. How correct is your measured value? Correctness, simply we can say. Now let's say we have two values. Let's say one value is 9.84 meters per second and we have another value that is 10.1 meters per second and these are the measured values, so we can say these two are measured values. So simply let's try to understand what exactly accuracy is. So we can say this value is measured value, and also we have actual value of G, so we can write on here actual value of G, that is equal to 9.81 meters per second. So now which one is more accurate? So we have two measured values, one is 9.84 and one is 10.1. so which one is more accurate? To compare these two, you have to look at which one is closer to the actual value. Mean how close the measured value is to the actual value. So you can see this value 9.84, this is closer to this value. So it means this value is accurate. So we will say this one is more accurate as compared with 10.1 meters per second. So this is more accurate. The question is asking you need to define what is accuracy. So we have defined accurate means that how close the actual value and measured value are, means how close the measured value is to actual value. So this is called accurate. But what is accuracy? Accuracy is the measure of how close the measured value is to the actual value. So question is asking us to explain what is meant by accuracy. So we can say it's a measure of how close the measured value is to the actual value, or you can say actual quantity. So this is how we need to define. I hope this makes sense to you. Now let me show you how you can write down the answer. So this is how you can write down the answer. This is very important one. For example, this is very important one. How close is very important. How close, this is very important one. This has to be in your answer, and it's a measure of very important one to understand. We can also say degree, you can also say so degree. So you can also say degree. So this is how we define accuracy. Part B says two solid cubes A and B are measured to determine the density of their materials. Table 1 shows the measurements for cube A. For part B1, show that the calculated density of the material of cube A is 8.7 times 10 to 3 kgs per cubic meter. So first of all, we need to understand how we can calculate density. Density is equal to mass over volume. So always write down the equation first. So we can say simply mass over volume. And mass in this case is given to us. Mass is equal to 31.3 grams. So we need to convert this one into kgs. So this is in kgs. As the shape is a cube, so simply we can take cube of one side. So we can write on 1.3 times 10 to minus 2, because this is given in centimeters, so we have to convert into meters. Now if we simplify this one, in this case we will get 8.7 times 10 to 3 kgs per cubic meter. So this is how you can calculate density of cube A. Second part says calculate the percentage uncertainty in the density of the material of cube A. So how we can calculate the percentage uncertainty in density. So simply we can write down percentage uncertainty in density. This has to be equal to percentage uncertainty in mass plus percentage uncertainty in volume, because density is equal to mass divided by volume. And how we can calculate percentage uncertainty in mass? So we need to take the absolute uncertainty, we have to divide by the mean value. So we have 0.5, this is divided by 31.3, and we have to multiply this one by 100 because we need to convert this one into percentage. But percentage uncertainty in volume is a little bit tricky. So let me write down here. So the fractional uncertainty in volume, delta V by V, and if you multiply, if you want to convert this one into percentage, so you will say delta V by V, this is equal to, let me explain a little bit in detail. Maybe some of you will be confused with this one, so let me rewrite again. So volume in this case is given to us, that is equal to L cube. So what is the fractional uncertainty in volume? This will be delta V by V. If we want to convert into percentage uncertainty, so we can say this is percentage uncertainty in volume. This has to be equal to 3 times, power has to come before delta L by L, and we will multiply this one by 100. Now simply we can write down here. So this is 3 times delta L by L. So we have delta L that is equal to 0.01 divided by 1.53, and we need to multiply this one by 100. So now if you simplify, you will get 4%. So this is the answer. Third part says the density of the material of cube B is determined to be 9.2 times 10 to 3 kgs per cubic meter, plus minus 6%, and this is the tolerance. We need to state and explain whether cube A and B could be made from the same material. So in the last part, we have already found density of cube A. That was equal to 8.7 times 10 to 3 kgs per cubic meter. And the density, this is the density of B. So we have density of B, and it has 6%. This is the tolerance. So we can determine the range of values for B. So density of B, it has range actually. So maximum possible value can be 9.2 times 10 to 3 plus 6%, means 0.06 of this value. So we can multiply with 9.2 times 10 to 3. So this is the maximum possible value of density of cube B. And we can simplify this one. If we simplify this, in this case, we will get 9.75. So we will get 9.75 times 10 to 3 kgs per cubic meter. So this is the maximum value of density of cube B. So we can say this is maximum. And what can be the minimum value? So we can determine 9.2 times 10 to 3 minus, now you need to minus 6%. So this will be the minimum value. So this is 0.06 times 9.2 times 10 to 3 kgs per cubic meter. Now if we solve this one, you will get in this case 8.6 times 10 to 3 kgs per cubic meter. Now here is the main point you need to understand. Now we have maximum value, we have minimum value, so we have range of values, range of possible values for density of cube B. Now we need to compare this one with the density of A. So here we have density of A. So if you look at these values, this is from 9.75 to 8.6, and this value is between these values, means is between possible values of B. So it means A and B, they can be made of the same material. So we can write on here. So this is 8.7 times 10 to 3 kgs per cubic meter. So we can say, as the range of values of B is from 9.75 times 10 to 3 to 8.6 times 10 to 3 kgs per cubic meter, and density of material A lies in this range. So they can be made of the same material. So conclusion, you can say made from same material, made from same material. So this is how you need to answer this one. So this is how we need to answer. So they can be made of same material. They can be made of same material. So this is, you have to state, they could be made of same material because density of A lies in the range of densities of B, so they have the same material. So question, you see, very important one, you need to read question carefully. You need to state. If you have stated, you will get this mark. And if you have proven this one, I mean this is your explanation, if you have done this, you will get the second mark.